All right, so for today's lesson, let's first concentrate on that word there. And earlier today, I've asked some kids what that word means, and that's been met largely with silence, which is kind of hard to swallow because you covered that before you got to me. You've already been introduced to inequalities this year. So even if it's not a formal description, even if it's not perfect, let's just start brainstorming. Somebody tell me something that they already know about inequalities. When you see that word, unequal, Hiram?
It could be equal, less than, or greater than.
There you go.
Or the same.
That's a good start. Yeah. That's actually pretty good. That's probably the best one I had today. You learned about inequalities this year right after you did equations. So you learned that an equation has an equal sign, and you're comparing two expressions, but that symbol, that equal sign, comparatively says that those two expressions are the same. But then right after that, you were introduced to inequalities, which can have one of four different symbols, and those symbols would either say that one expression is less than the other one, greater than, less than or equal to, greater than or equal to. Does anybody claim that they don't remember that? Okay. Now, part of what you learned already should have also involved graphing. Now, yes, inequalities like equations can be solved, but when you learn about equations, I know that recently we have graphed equations as well, but you'll see the comparisons coming up in the lesson. Back at towards the beginning of the semester, you learned how to solve an inequality, and like let's say we already finished solving and we get like x is less than or equal to 4. Well, how many variables do you see there? One. So when it comes to graphing one variable can be graphed on one axis. So that's what you should know. You should know those concepts already. We'll review them quickly, but then what today is about getting these concepts from one axis and applying them to two axes. What do I mean by axis? Well, a number line. You learned how to graph on one number line. Depends on the teacher as to what maybe they make you populate that number line with. Like I would only make my students put the number that they got on the other side of the number line, because that's really the only number that's important. But maybe some other teachers have you put like some integers doing 2, 3, 4, 5, 6 around there. But the only number that's important here is the 4, and then you should have learned, okay, well, hey, what type of point do you put on the 4? Well, your two options were open or closed, and in this case, because we have an or equal to sign underneath, you would put a closed point. But what that teacher may or may not have emphasized to you is what that point was acting as. Okay, what it was acting as a divider. It was acting as a boundary. Because on a straight line, physically, if I get 1 point on a straight line, that 1 point is enough to act as a barrier. I can split that straight line up into sections, which in this case was a left or a right. And one of those two sections ended up being your solution, and I would demonstrate that by shading the line. Now, hey, look, geometrically, just for accuracy, it's actually called a ray. What you end up shading looks like what's called a ray, but that's a geometry thing. You haven't got to geometry yet, so if I write ray here, you guys don't know what that means. Well, let's just call it a line. Where would I shade on the one that I just put up on the board? Use your words. I would shade left. Okay. Now, where I have a little bit of a beef is why I use shade left. See, and I found that over the years, more and more kids, when I ask them to tell me why they shade left, they're like, oh, because look, if I look at the inequality sign, I visualize that it's an arrow, and that arrow is pointing to the left. How many of you shade because of that? See, the problem with that method is that that only works if the variable is on the left side. If the variable's on the right side, yeah, that's different. Now, if you know how to adapt to that, that's on you, whatever, that's fine. The way that I learned when I was young, and that I still teach to this day, is instead of looking at the closed end of the inequality, the part that's closed, look at the open end. When I was in elementary school, they taught me to think of it as an alligator mouth, and the alligator's hungry. But I don't know how to draw an alligator, so nowadays I just draw Pac-Man. Okay, and Pac-Man's hungry. So when you give Pac-Man two options, it's going to take the bigger of the two. So right now what Pac-Man is saying is that 4 is bigger than X. X small. On a horizontal number line, where do small numbers go?
Left.
To the left, and that's why you shade the left. Okay. So now what's going to happen is we're going to get these same principles and apply them to two axes. Meaning instead of one variable, there's going to be two variables. Take a while to guess what those two variables are going to be. X and Y, sure. Now with one variable equations, right before we learned about inequalities, if I were to say, X is equal to 5, those we did in graph, but once we got to two variable equations, where we said, now, hey, Y is equal to 3X minus 7, yeah, those we have graphed. We took a test on it right before we went on break. So now we're going to do the same thing, two variables, but now some type of inequality. So how do the concepts carry over? Well, what used to tell me what type of point to put on one axis? The little or equal to sign underneath, right? If I had this little, the possibility of being equal to. Well, now what used to be an open point is going to become a broken line. The reason being, well, when I have two variables, I'm not graphing on a number line, I'm graphing on a plane. Not an airplane, but like a coordinate plane. And if I take these axes off, because maybe it's harder to see, really what you're graphing on is a flat space. Now I could get these axes to measure that flat space, but I'm graphing on a flat space. And just like with the line before, I have to break it up into sections. With the line, it was just left and right. Here's going to be a little bit different, but I have to break it up into sections. If I think of this as being a football field, and I need to tell, hey, the football players, the offense goes to one side and the defense goes to the other side, and I just put one cone somewhere on the field, is that going to do a very good job of maybe letting the football players know where to go? No. Probably not. Yeah, well, depends how much you yell at them, right, Hiram? But if I were to get a line, I don't know, maybe some type of like tape or something, or like the lines that they draw on the field, let's do that, the lines, and say, hey, this is the 50-yard line. Offense goes on one side, defense goes on the other. They probably have a better, I have clearly broken this up into two sections. So that's what the boundary is going to do. What used to be an open point is going to be a broken line. What used to be a closed point is going to now be a solid line. And you have to be careful with it, because if you do everything right, but you put the wrong type of boundary, it's going to be wrong. Shading, what we used to shade in as a solution being a line, is now going to be a section. Okay, we're going to shade in the section of the graph. But before, your options were going to be left and right. Well, now when we graph, when we had equations, we learned 3 different forms for equations. What were the 3 forms we learned? Standard form, point, slope, and
standard equation.
and slope intercept. Slope, intercept, point, slope, and standard. Well, when we graph inequalities, we're only going to graph out a slope, intercept. What makes something be in slope, intercept? Y is by itself. So what are these going to have in common before we graph? Y is going to be by itself. What direction does the y-axis go? Up and down. So now when it comes to shading, we're not going to ask you left and right. We're going to ask you up or down. If your boundary is pretty flat, if it's pretty horizontal like this is, well, yeah, judging what's up and what's down is pretty easy. But if I have a boundary that's kind of steep, you're going to have to still make the same determination between up and down. You're going to have to know what's up and what's down. We're not going to be asked what's left and what's right. So I'll try to show you a little gimmick that we use to try to help remember. Let's get to the examples. Jonathan's been waiting. We don't want to make Jonathan wait. Okay, so I want to graph this. What's good about the graphing? Y is by itself. When Y is by itself, how do we graph? We identify slope and y-intercept. Jonathan, what's my slope here? No. Blanca, right? Blanca, yeah. Blanca, what's the Danny? It is 1. And for graphing purposes, it also acts as a fraction. So we'll write 1 over 1. Crystal, what's my y-intercept? Good. I'll write that as a point 0, -3. If you knew how to graph a line, this is not the same, but it's a much easier transition. If you don't know how to graph a line like an equation, this is going to be next to impossible. So I'm going to start this at 0, -3. I have to know that my positive slopes take me up, right, and down, left. So up 1, right 1, up 1, right 1, up 1, right 1, or down 1, left 1. How many points do you have to show? Well, I guess I always prefer 3, but I guess the minimum is 2. Now, Hiram, before you get so excited and you just draw a line, remember that now the line is not the solution. It's not the answer. The answer is a space, but you have to know how to define that space. And part of defining that space is knowing that there's 2 types of boundaries. When you draw that line might be solid, but it might be broken. So what determines that? The inequality sign. Because I have the or equal to sign underneath, is it going to be solid or broken?
Broken.
Solid. It is going to be solid. Muhammad will trust. So make sure that this one is going to be solid. Another question that I had, I think it was a different period, but back when we were doing equations, somebody asked me, hey, Mr. Romero, how long does the line have to be? Like physically, how long does it have to be? Well, if you're graphing an equation, it only has to be long enough to connect the 2 points, because as long as you're putting arrows, the arrows mean that you go on forever. But now I have to be able to define a space. So here, my space, what's called the window, my window extends 12 units in every direction. I need to be able to clearly split that space into 2 sections. Your space might be smaller, you might have a smaller window, but however big your window is, you need to make sure that you drag that line, or use your ruler, to take that line all the way to the edges of the boundary. Yeah, you still put an arrow, but I need to be able to say, hey, look, now when it comes time to shade, here's one possible section I would shade, and then here's another possible section I would shade. If I don't have a long enough line, I don't know what's going to be happening here in the corners. All right. Mohammed, do you feel that you know Hiram pretty well? Yeah. Do you know that he likes hiking? He likes mountain climbing? He's ever told you that? It's one of his hobbies when he's not playing football or sleeping in class. He likes to climb mountains. So if we were to put Hiram on this mountain, This is what's gonna help you shade. Because if this boundary, like the next thing I'm about to ask you is to shade up or down. And if that boundary was pretty flat, well, it's pretty easy to tell what's up and what's down. But the steeper it gets, some people struggle with what's up and what's down. So the way I like to think of it is, well, imagine this was a side view of somebody climbing a mountain. Or have you ever seen, I don't know, well, is there like a county fair? Is there like a Gwinnett County Fair? Or if you ever been to like a carnival or anything like that, they have the little thing where you shoot the water, and then the little bird like yodel, 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 and they're like climbing up to the. You have the here's Hiram climbing the mountain with his hat on, with a little feather on his hat. Yeah, and he's yeah. So when Hiram goes to that mountain and he looks up, what is he gonna see? The sky, sure. And even though he's on a slope, when he looks down, what is he gonna see? The ground, yeah, the ground. So what's the variable that's by itself? Y. Where does Y go? Up or down? Mouth eat Y, mouth hungry. Mouth eat Y, shade up. Big Y, big Y's go up. Mouth no eat Y, Y little. Where do little Y's go? Down. So here the mouth is not eating the Y. Where are we going to shade? Down. So on this picture, if I visualize Hiram on that mountain, I'm going to shade where the ground would be. Well, I'll race you and see who can shade faster. I think Jonathan's going to win. He's an excellent shader. Hey, Jonathan, what's your favorite color? Like goldenrod? No. Julian? Well, see, that's pretty simple though. So like, wow, that you make this look so hard, but it's so easy. Well, okay, but what does it mean? Like, even if I can get you guys to follow directions and do it properly, what does this graph represent? What does it mean? How does this graph relate to the inequality that we were given? No, the shading is the solution. What I colored in, that's the answer. Yeah, there's a lot of answers, an infinite amount, but anything that falls in what I do as yellow is considered a solution. So Hiram, give me just, and I'm not gonna do this every single time, but for this first one, give me a point that's in the yellow. Any point you want, as long as it falls in the yellow.
-5.
Okay, that's not a point. I need an ordered pair.
Oh yeah, that's -5. And 3.
Okay. Okay, -3 and 3 falls in the white. So go ahead, Danny, help him out. 4 negative. Okay, just to help it'll work, but I feel like using the 4s might confuse some people. Can you just give me 2 different like digits?
All right. 4.
Okay, perfect. Why you're stretching it all the way again, but perfect. Okay, so 12 -8. We would all agree that 12 -8 falls into the shaded region, right? So what should happen is I should be able to get any point that's in the shaded region and go in and plug it up into the inequality and get a true statement. So let's see if that works. If I put in the y he picked was -8, that should be less than or equal to 12 minus 3. 12 minus 3 is? 9. It is 9. Is -8 less than or equal to 9? Yeah, sure. Yeah, it's not equal to, but it is less than. It just has to be one or the other. Let's go the other way with it. Elizabeth, give me a point that falls on the white. She says -3, 2. Okay, I agree with her. -3, 2 does fall into the white. Let's see what happens here. Now her y was 2, and then her x is negative. What's -3 minus 3? No, it's not. It's -6.
Oh,
Is 2 less than or equal to -6? 2 is not less than -6. It's also not equal to -6, so that would be false. Any point in white would be false. Any point in yellow would be true. I was actually surprised last period, somebody on their own, without me telling them to, brought up an interesting point. I just mentioned to you what happens if you pick a point in the shaded region. I talked to you about what happens if you pick a point on the non-shaded region. Ah, yeah, what happens if I pick a point on the boundary? No, why do you like -3, 3 so much? That's just, you guys have that on your mind? No, like on the boundary, like on the red. Like for instance, here on -2, -5. -2, -5 is on the boundary. So is that a solution or not? So let's do this. So instead of answering that question now, let me wait till the next exam, and I'll answer it after that one. But I do want to poll the audience. How many of you think that a point on the boundary is part of the solution? Raise your hand. If you're on the boundary, that you're considered to be part of the solution. Like on the fence, okay? How many of you feel that if you're on the boundary, you're not part of the solution? You're part of the bad guys. Hiram, you just want to do both? You're just trying to fit in? 50-50, okay. Noted. We'll keep that in mind that you're 50-50. Ariana, y is by itself. What's the slope here? It is. We'll write it as a fraction to help us graph. And Caleb, what's the y-intercept? -2. Yeah, I'll give you guys a head start. I'll give you like a 45-second head start. Let's see if you can graph. Don't be scared. Have you figured it yet? All right, so I gave you a head start. So -2 is where I started the graph. My slope is -0. So if I go up 3, I have to go up left 1. That's the first thing you would be aware of. What type of boundary should I have?
broken.
It better be broken, yeah. So if you just got carried away and drew a solid boundary, that's wrong. I have the marvel of modern technology by my side. You guys will just have to use your straight edge, your ruler, and just kind of like break it up a little bit. So now here's Hiram. Yodelay, yodelay, yodelay. You want the hat? I'll make it green this time. With a little red feather. And then you're shooting the little water gun into the it's coming up. Is the mouth eating the Y?
No.
Yes. Y big then. Mouth eat Y. Y big. Where do big Y's go? They go up. So where would the sky be? Right. Yeah, it's very good. It'd be the same in this case as on the right. Yes. That would be the sky. Please, on your test, don't draw stick figures. You can do it at home if you want. Y gets Eden shade up. Y no get Eden shade down. And now let's answer the $1 million question. One more time. Okay. If I were to pick any point on the yellow, and I plug that in, it would work. For now, just take my word for it. If I pick any point on the white and I plug it in, I would not have a true statement. But now let's go to the boundary. Raise your hand if you think on the boundary would be part of the solution. Raise your hand if you think the boundary would not be part of the solution. And Hiram is still 50-50. If, for the solution, you raise your hand on the first one and not on the second one, those are the only two that are correct.
So, if it's on the line.
No. Not necessarily. Let's see. Let's compare. What's the difference between the first boundary and the second boundary?
The first boundary is south.
Well, yes, you could argue that they're going in different directions, but no, that is not the decider between. That's what he's talking about, is direction. And yes, fine, you can make the argument that direction is different, but let's ignore the direction has nothing to do with whether it's part of a solution or not. That also has to do with the direction. You guys are overlooking something that's a lot more plain. Andrew? There we go. Very good. That's the bigger difference. One is solid. One is broken. Solid boundary, part of shading. If you shade the boundary, that's considered part of the yellow. Broken boundary is considered to be part of the white. So if I were to pick a point here like 1, -5, 1, -5 is not part of the solution because it's part of a broken boundary. Yeah. It might be. Is that too hard for you to learn? I believe in you, Hiram. He knows all the designers. What's different here? That's the main one. That's what I'm doing. The Y is not isolated. For inequalities, we said we only wanted to work with slope-intercept form. So let's put this in slope-intercept form. Luckily, this can be done in one step. We add 2x like the cool kids do. And then now we have y greater than or equal to 2x minus 4, just like the last time. I'll give you like a 45-second head start. See if you can graph it on your own. Don't poop. It's bad for you. Hiram's a silly boy. Okay, so what you should have identified is that your slope is going to be 2 over 1. The y-intercept is 0, -4. The boundary is going to take you up 2, right 1. Okay, who says solid? Who says broken? And you want to be 50-50 on this one? No, you would have been better off being 50-50 because it is solid. And it has the, if you have the or equal to sign underneath, it is solid. Oops, don't want that. Okay. And without drawing a yodeler on the side of a cliff, what are we gonna shade the sky or the ground? The sky. Mouth eat y big. Shade the sky. Mouth eat y big. Big y's go up. We actually did go up last time. Yes, we did. It was just that we were on the other side of the mountain. Instead of climbing up from Tibet, we climbed up the other side of Everest. And then Nepal, it's Tibet and then Nepal. Where? Mongolia? Poland? No, Poland is nowhere near Mount Everest. You're talking about Dookie? Your lunch tasted like Dookie? Any question on the graph? All right, let's do this next one together. What looks different about this one? Okay, the main thing is that y is not isolated, but you might say, Mr. Romero, on the last one, y wasn't isolated. Well, okay, you'll see the difference now when we start solving. When we start isolating the y. John, what do you want to do first, buddy? Never mind. Charles, what do you want to do first? Very good. That's what I would do also. I want to get y by itself, so I would add 4x. We're all experts when it comes to like terms, so we know that those can't be combined. And now here's your difference. Morgan, what's my last step? Shut. Your name is not Morgan. Very good. Divide by a negative. 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 Did you make that clear? If Morgan would have said multiply by a negative. Same thing. What you should have, and this is not a new concept. We're going to be applying it differently, but this is a concept that should be familiar to you. In any inequality, if you multiply or divide by a negative, what should happen on the next step? The inequality sign flips. So, yes, I'm going to have my y. I can divide each of these by -2. So I would get -2x and -3. But now, instead of the mouth facing towards the left, now the mouth is going to face towards the right. It's Dookie. We put a point on -3. negative slope is going to be up 2, left 1, up 2, left 1, up 2, left 1. Well, all the lines are straight. But Hiram is going to be solid or broken? Solid. Oh man, you're having a bad one today. Do you see an or equal to line underneath the mouth? It's all Muhammad's fault. If you cannot take Muhammad to the mountain, take the mountain to Muhammad. Shade up or shade down? Good. Mouth is not in the west, shade down.
Oh, yeah.
You feel me? Yo, we haven't shaded down in a minute, son. Can you tell that I have a cool tutor that I've been paying to like take cool lessons?
What?
I'm trying to sound cooler.
What?
The same way that you guys get math tutors, I have a cool tutor teaching me how to be cool. Cool, like a cool tutor, COOL.
Get those.
On Craigslist.
What did he say?
Because he's realizing just how cool I am. Any questions here? All right, these last two should be quick, so let's just let's get through these and then you can miss me for the next 24 hours. What's different about this one? Okay, say it better. Okay, you can say no X, or you can say one variable. I don't know about one number, but yeah, one variable. I skipped one, and this is the next one, and it's gonna come back. Just skip one more. Okay. So yes, the first thing I should have heard is that there's only one variable, and then when I asked the follow-up, well, what variable is missing? Hiram would have said we're missing an X. Now, the good news is that the variable that is still there is the Y, and the Y is the one that we've been isolating. Okay, so we're still going to have a slope, and we're still going to have a y-intercept, but it isn't as important. I don't think that the slope and the y-intercept are going to help you graph here. These types of graphs, when you're graphing one variable on a two-variable plane, it's just memorization. Yes, there's a slope. The slope is 0. Yes, there's a y-intercept. The y-intercept is 0 too, but that's not going to really help you. It's just memorizing. Now, sadly, you guys always memorize the wrong thing. Because you think y, and you think y, up and down. So let me draw a vertical line. No. Find 2 on the y-axis. Your line is 1 point. And then draw a horizontal line through it. Now, Hiram, is that going to be solid or broken? Good, solid, good. And I'm still going to ask you up or down, but now up or down is a lot easier to tell. So is this one going up or down? Mouth eat Y, Y big. It is going to be up, and again, you shouldn't have to be visualizing any mountain climbers or yodelers or anything. Up is obviously.
I have a question.
Yeah. Yes, go. Ask. Ask and ye shall receive. No.
I remember my question.
What's your question?
Remember when you did negative
and then they will say the same. Okay. One more. What's different?
Oh, you got a fraction.
There's no fraction. Yeah, I skipped 2 ahead, now we're coming 1 back. Yeah, here there's no y. Before there was no x, now there's no y. Well, that's a little bit different because without a y, we actually have, like, our slope is undefined and our y-intercept, like, they don't exist. There's no such thing as a slope. There's no such thing as a y-intercept, but that's not going to really help you. Okay? What will help you is say, okay, well, if I can memorize that when there's a y, it's supposed to be horizontal. When there's an x, it's supposed to be vertical. Find negative 1 on the x-axis and draw a vertical line through it. Hiram, is it going to be broken or solid? Welcome to this problem. Good. Is it gonna be, it's going to be broken. There's no or equal to it. And don't tell me it's vision, because earlier today you could read that it said midterm up on the board and nobody else could read it. So. Whoa, but now, see, hold on, before I get too excited that class is almost over, what? Wait, I'm supposed to shade up or down. I can't tell what's up or down. Well, remember, the reason why we were doing up or down is because what was the variable that's by itself? The y. Y goes up and down. But if all I have to work with is an x, what direction does x go? Left and right. So now my options are left and right. Mouth eat x, x big. Where do big x's go? Right. To the right. These are actually, you could argue that these are the most similar to the inequalities that you've done before. So tomorrow, we'll take whatever time we have together. We'll finish these.
Since today we have a modified schedule, we'll finish the examples that we didn't finish yesterday. Even if your name is Hiram, you can still take out the packet. Okay, here we have y isolated, so what's my slope going to be?
Oh, let me see, 1.7.
Negative 305.
Thanks. You're welcome. And Jordan, what's my y-intercept going to be?
Zeros.
Good. What's your name, bro? You ready? Are you with us now? Like on a scale from 1 to 10, how much of you is here right now? 10 being like fully here, and then 0, actually yeah, 0 being not here at all. I'll take that as like a 4.5.
Right.
Alright, so our first point is going to be at 0, 0. We have to know that positive slopes go up into, negative slopes go up into the left and down to the right. So up 3, left 5. Or you can go down 3 and to the right 5. Crystal, what type of a boundary is that going to be?
That's crazy.
Yeah, it's going to be broken because there's no or equal to sign underneath. So I draw my little hill, and then we're going to sing songs while we climb the hill, and then while we're climbing we're also going to be shading, but are we going to shade the sky or shade the ground?
Sky.
Yeah, the mouth is eating the Y, so we shade the sky. Any point that falls in the blue region would be a solution to the inequality that's listed above. Any point that falls in the white area would not be a solution. How about any point that falls on the boundary itself? Not a solution. Why not? Because it's negative.
Broken.
Because it's a broken line. Yep. It's a solid. Solid boundaries are part of the shading. Broken boundaries are part of the not shading. Okay, for this one here, I'm going to give you like a 60-second head start. I don't need you to graph it yet. I just want you to solve for y. These are things you should be able to do. You have, besides this lesson, you have a midterm coming up next Friday. Yeah. Just waving.
Red house, look. That's green.
Yes, sir.
I sharpen my pencil.
Can you sharpen your pencil? Yeah, man, absolutely.
Yeah.
Yeah, sure. Maybe tomorrow when you get here, instead of like being so popular, you can just do that first, like before the boat and the sweater. I even got a sharpener that has your name all over it. It's over there. It's the same color as your sweater.
That's green.
I really do have a sharpener. It's better than that one. Are you scared of it? Okay, so if you solve for y like you were supposed to, the first thing you should have done is subtracted 8x from both sides. Negative 3y will drop down, less than or equal to negative 8x minus 15. Then we divide by negative 3 on both sides. Y will not be by itself like I wanted it to be, but what can I not forget?
You have to flip the side.
Thanks, Mohammed. Yes, you do.
Thank you.
But then I have to divide each term by negative 3. Negative 8 cannot be divided by the negative 3, but the negatives do cancel, so I would get positive 8 over 3. Put the x off to the side. What's negative 5 divided by negative 3? I'm in the wrong seat, man. What's negative 15 divided by negative 3, Harry?
Negative 15 divided by negative 3 is negative 5.
No.
Negative 15 minus negative 5. It's 5.
It's just positive 5.
I said that, right?
Angel, what's my slope?
8, negative 8. I mean, no, 8 3.
Yeah, it was 8 over 3.
I thought that was a negative, my bad.
It's okay, I don't have the best handwriting. Blanca, what's my y-intercept? 5. Good, 0, 5. So my first point will be at 0, 5. Then my slope, positive slopes go up and to the right or down and to the left.
Up to the right.
The window that I have provided myself doesn't give me enough space to go up 8 because I'm at 5. If I were to go up 8, that put me at 13. So I haven't given myself enough space to go up, so I'll just go down then. If I go down 8, then I have to go to the left of 3. Because positive slopes go down left or up right. And then if I do that again, negative 11. However many points you choose to plot should all line up. What up?
It's a straight line.
It's a straight line?
Straight.
Oh. Kayla, what type of boundary is that going to be? A what? Solid, yeah.
How would I say it?
Oops. Don't want that. Okay, Hiram, where am I gonna shade the sky or the ground?
Let me see. You're gonna shade the sky.
Yeah. Mouth eat Y, shade sky. Cause it spit hot fire.
Yes.
Are you hitchhiking? You wanna go somewhere? Any questions?
No, sir.
Why do I have like more than one kid that does that? Is it like a thing that's going on now, or just like you don't like your ears are cold or something?
What?
Where like they put the hood just like over the ears.
Oh, no, I've just been doing that since 5th grade.
That's just you? Because I have another kid that does the same thing in a different class. I get you confused. It's Elena, right? Here and then so Elena, how would I isolate Y here?
Minus 2x
For show. So then Ariana, what's the slope going to be? Negative 2 over 1. What's the y-intercept going to be? 0. So I'll start off at 0, 1. Negative slopes take me up left and down right, so I can go up 2 left 1 or down 2 right 1. Jonathan, what type of boundary? Good, yeah, it is going to be a broken boundary.
Yep.
And, yeah.
Are you gonna have a quiz on it?
You might. No, I'm just kidding, you won't, because the midterm next week.
Well, we're gonna have a test on this.
You have a test coming up, but it's not going to be just on this. It's going to be mostly on systems. That's at the end of the month. It's already on the calendar.
Is that a new?
Systems of equations, systems of... Actually, we don't do systems of inequalities, just systems of equations. Sebastian, you know what? This is the second class in a row I do the same thing. Something's wrong with my eyes. Okay, there you go. That's better. I went down 3 again. Alright, so Jonathan said it's broken, but then Sebastian, am I going to shade up or shade the sky or shade the ground?
The ground.
Good. Any questions? Hiram, do you have that on your paper? It's a good thing you sharpened your pencil though, because if not, it would have been harder to not write it. Charles. I want to solve for y. What do I do first? That sounds good. Morgan, what do I do next?
You divide by 2.
Divide by?
3.
Very good. Parag, do I flip the sign?
No.
No?
Yes, you do.
Because of your phone? Who says flip the sign? The inequality sign. Who says don't flip the inequality? Good, why don't we flip it?
Because it's not negative.
Let's see most of it. Because I am not dividing by a negative. I am dividing, but not by a negative. So.
You sure?
Negative 2x divided by 3 is negative 2 over 3x. Negative 15 divided by 3 is negative 5. Slope is equal to negative 2 over 3. Y-intercept is equal to 0, negative 5. So, start at negative 5. Up 2, left 3. Down 2, right 3. Negative slopes go up and to the left or down to the right. Andrew, is going to be solid or broken? Solid, good. Hiram, where do you want to shade?
Oh, we're going to shade up this time.
Up, yes. Shade the sky. Good. Oh. Hiram, I'll raise you to see who shades it first.
You gotta catch up, Mr. Ramirez.
I win.
You won.
Hiram, is the point, is the point 3, negative 7 part of my solution?
Point
3, negative 7. Is 3, negative 7 part of my solution?
3, negative 7. Let me see. 3, negative 3, and negative 7.
I'll help you out.
Yes, 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 yes.
3, negative 7. You say yes. Why yes?
Hold up. 3, negative 7. So you're talking about like down 3 and negative 7 left.
No, 3, negative 7 means 3 to the right and 7 down.
Hold up. 3 to the right and 7 down? No, that's, hold on, what? Hold up, let me see. 3 to the right is 7 down. Oh, that is right.
So is it part of the solution or not?
Yes,
Why?
because it's a solid line.
Good. That's exactly right. It's a solid boundary.
Yeah. No. Okay.
Elizabeth, what do you want to do first to solve for y?
Minus the 5x.
Yeah, minus 5x sounds good. We drop down to negative 2y as if it was hot. Normally you cannot combine a constant with a variable, but there's nothing on the right side. At the beginning there was nothing there. 0 minus 5x is negative 5x. The set, what's the last step? The set, last step. Y by itself. Cancel out the y. Danielito, want to get the y by itself. What's the last step? Divide by -2. So Parag is very astute here. He sees that that we divided by a negative, so he'll flip the inequality. So now the open end is facing the right.
Start right here.
My slope is 5/2. My y-intercept is 0, 0. So this boundary is going to pass by the origin. 0, 0, up 5, right 2. Make sure you don't get that confused. Don't go up 2 and then right 5. Hiram, you were confused about directions. Remember to just pull over and ask for directions. Minus, down 5, left 2. Jonathan, solid or segmented?
It's going to be segmented.
Good. Hiram's diagram.
Let me see. No, that's the ground.
Yep.
Because the Y, no, the alligator's not eating the Y.
Yep. The mouth is not eating the y. That means the y is little. Little y's go down.
Big Y. I can tell.
How many of you already started working on
The last one, the whole
the Khan Academy? And you were able to find it on the...
Oh, no, I didn't do it. I just did the written part. Yeah, I finished the written part.
I did the written shit.
Oh. Okay, even if you're going to do the written one, that's fine, but remember to log into Khan Academy, because for next week, the long assignment is...
You sure?
Is all Khan Academy, and I want to make sure that you guys are able to log in. Ideally, I would like for you to start beforehand.
I got you.
Any questions there?
No, sir.
All right, last one.
Last but not least.
Go ahead, Mohammed. What do you want to do first?
Subtract the 8x.
That sounds good. Mohammed, what drops down on the left? What's going to drop down on the left?
Yeah, negative y.
Negative y, yeah, don't forget the negative. You can handle it from here? Okay. And Hiram, we trust. Go ahead, Hiram.
Okay, so you're going to have to minus the negative y.
Definitely not going to minus
that, you got to flip the sign. Oh, you got to divide the negative y. Negative 1. Negative 1. Negative 1.
Now look, okay, you are not incorrect. If you divide by -1, that's perfectly fine. That is allowed. You gotta remember to flip the sign. There's nothing wrong with that. But there's something called the multiplication property of -1, which you should have learned. That says, well, look, if the reason why you're dividing is just because you want to change the sign, well, then don't divide. Just multiply by -1, and it'll do the same thing.
Alright, that's going to be...
I don't know if it's better or harder for you to remember. I don't know, but it's the same thing happens. You'll normally see it done this way. So y greater than or equal to 8x minus 4. 4 out of every 5 Hirams agree that the slope is 8/1. Y-intercept is 0, -4. So I'll start off 4 below the origin, go up 8, right 1. I can do that twice if I want, or I can go down 8 and left 1. Let's set, is it going to be a solid boundary or a broken boundary.
Let me see what it is.
Yeah, it is going to be solid. And then are we going to shade, let's set the shade the sky or shade the ground? Mouth, eat, Y, shade the sky. If this were a picture of little Muhammad climbing his mountain.
That's a steep mountain.
Yeah, it is steep.
I can't do
Yeah,
that.
yeah.
I would this way.
You'd have to be like Spider Muhammad.
This cousin. This cousin.
The sky would be over here.
If you're translating, this cousin. Oh, bring that over here. It's like a carpet. Huh?
Okay, any questions for me? Okay, I don't know when the bell's gonna ring, so you can work on the written assignment if that's what you're gonna do for the week.
Can I turn in my homework?
Then you're ahead of the game.
Thanks. That's why they pay me the big bucks. I can teach you this real quick. It doesn't, like, everything that goes into this we have learned. We just haven't done it together. Here's the big difference. If you think of the graph as being like a window, these are inequalities, right? We've graphed one inequality at a time. If you graph one inequality, there was like a boundary. And then I remember I taught you there was like, oh, here's little son of Jair on the hill. And then, oh, is the mouth eating the Y? And then if the mouth was eating the Y, we shade the sky. If not, we shade the ground. You remember that part? So here's the only difference. When I only draw one boundary, how many sections does that break the graph into? How many? Two. There was two options. It was either sky or ground, and you would shade one. Whereas when there's two boundaries, how many sections does the graph broken up into? Yeah, it's 4. But you could still only shade one. So I find the best. The thing is, you have to look for the overlap. You have to look for the overlap. So I find that the best way to teach this is actually to take a step into another discipline. This one would be art. Go to the realm of art. Look, Georgiana, we're going to do art class now. We're going to take a little 3-minute break and do art. Do you like art? No? Primary colors. What are the 3 primary colors? Red, yellow, blue. Okay, I agree with that. I'm going to use blue and yellow. So if what I'm looking for is an overlap, and I'm using primary colors, specifically blue and yellow, if there is going to be an overlap anywhere in this paper, what color would magically show up even though I'm not using it? Green, because blue plus yellow equals green, right? Okay, so before I get into shading, let's make sure the boundaries are correct. Neither of these inequality signs have an or equal to, so they all have to be broken. All the boundaries have to be broken. So like really, I know that this cannot be this has a solid line, so it can't be B. This has a solid line, so it can't be B. So I'm down to either C or A. Then when it comes time to plot these, both of these inequalities are in slope-intercept. So that's why Emiliano knows that the slope of the first one is 6/1. The y-intercept is 0, -3. Then Jair's like, yeah, but look, the slope of the other one is 1/1, and the y-intercept is 0, 2. So if I look at this, it actually ends up being the same for A and C. They both have a boundary that's crossing at 2, going up 1, right 1, up 1, right 1, and they both have a boundary that's crossing at 0, -3, that's going up 6 and right 1. So the only difference between answer choice A and answer choice C is the shading. So let's see if we can figure this out on our own. Ignore the fact that part of this A is shaded. Let's pretend that there was no shading there on A. And I'm gonna start with the yellow. So let's shade this first inequality, the one with y less than or equal to 6 minus 3. So if I ignore the other boundary, I'm only going to look at this boundary here that was crossing at -3, where the slope is positive 6. And if little Jair was on that hill, it'd be a pretty steep one. He'd have a tough time staying on the hill. But if he were, since the mouth is not eating the y, would I shade the ground or would I shade the sky? If the mouth is not eating the y. The ground, yes, y littles go down, so it's like a little coloring book. I'm ignoring the other one, I'm only paying attention to this boundary here. Okay. But then little Colin decides that he wants to climb the other hill. So if I go look at the other boundary, the mouth is eating the y. So if mouth eats y, where do you shade? The sky. So I'm gonna start shading this one blue. So it's like blue, 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 blue. Whoa! What is that? What just happened? I didn't even use a green marker, and look at that. Some green showed up. So is there an overlap? Yeah. Where's that overlap occurring? In that little skinny section on the top, which wasn't shaded on A, but it is shaded on C. Answer choice C. You writing that down, Akai? I hate to see what your sad face looks like, and that's like happy face. Fear the flutes? You guys have intimidating flutes?
Yeah.
There is a skull there, so that's scary. All right, so and we're here today until 12:34. I still got 30 minutes. Ooh, solve each system by substitution. Yeah. Okay. So let's be clear on this. I highly doubt that there's gonna be an instrument available to you on the final exam that could force you to solve a system a certain way. Meaning, like, even though if this were to be a problem on the test, yeah, would you normally solve this using substitution? Probably not, right? Because what would be better off here? Y elimination. Both equations are in standard form, so I would use elimination. I had a student last week that asked me, "Oh, but if I do this with substitution, am I gonna get a different answer?" No, you're gonna get the same thing. So I'm gonna do it by substitution because that's what the directions say to do. But at the same time, I'm letting you know that on the test Wednesday for you guys, if all they're asking you is for a solution and there's no way for them to check how you do it, then do it however you want. Now, if I'm gonna use substitution, I have to solve for a variable. What would be the best variable to probably solve for here? Variable, letter. Okay, but which x? I see two different x's. Which x? The top x, because that one has a 1 in front. So I'm going to go plus 3y and plus 3y. So I get that the top x is equal to 3y minus 3. So now I can go substitute and say -8, oh, not times x, times 3y minus 3 plus 5y is equal to -14. How has substitution helped me? What have I accomplished due to the fact that I substituted? Now there's only one variable, so I can solve. What's the slope of the first one? -2/3. What's the y-intercept? 0, -1. For the second one, what's the slope? -2/1. Because we want to write as a fraction for graphing purposes. And the b is at 0.3. All right. So that's the first thing I'm going to look for. Just that when instead of equal signs, when you have inequality signs, we don't call them lines, we call them boundaries. But that's what we're looking for. Do you notice how this one here is like kind of like segmented? A segmented boundary is if you did not have the or equal to sign underneath. If that little or equal to is not underneath, that's when it would be segmented. But here, I have or equal to on both of them, so I'm looking for two solid lines. I'm looking for two boundaries that are solid. So I already know that it can't be B, but it could be the other ones, okay? Now let's see, we're looking for one that's going to cross at -1 with a slope of -2/3. So here we're crossing at -1, but it looks like we're going up. Oh no, this one way, it's going up 4, and then running 3, 4/3. So it doesn't look like it could be A. Let's see, C at -1. There's not even anything crossing there at -1. This last one, B, yeah, that one looks fine. And then the other one is supposed to be crossing at 3 with a slope of -2/1. Yeah, so it's going to end up being D. I'll show you one last thing, and normally this takes an entire lesson to show you guys. If you pick up on it, great. If not, don't worry about it. Hopefully it doesn't show up on the final. But how do we shade in? Okay. Well, here's what you're supposed to do, right? Think of these. Just go one line at a time. Let's go with the first one, when I was crossing at -1. And pretend this was a hill. And here's little Ferris climbing the hill. Okay. Can you picture that? Ferris is going to climb up the hill. If that was a picture of Ferris walking up a hill, what would you see in this part of the picture? If we're outdoors and that's Ferris climbing up a hill, what would you see in that part of the picture? If I drew it in this color, would that be better for you to visualize? What would be on this part of the picture if that was little Ferris climbing up a hill? The sky, yeah, it'd be the sky. And what would be on this part of the picture if this was Ferris climbing up the hill? The ground or the hill, right? So on an inequality, since y is the variable by itself, if the mouth is eating the y, you shade the sky. If not, you shade the hill, the ground. So the first hill that Ferris is going to climb up is this first inequality that was up here. Is the mouth eating a y there? So mouth eating y is big, you would shade the sky. So watch. I'm going to pretend that the other graph is not there. I'm only going to focus on where the sky would be, and I'm going to shade all of this stuff. This is the sky of the hill that Ferris was climbing up. Can we agree on that? So now Ferris decides to challenge himself. He goes, oh yeah, that hill, it wasn't steep enough. I want to climb up a steeper hill now. So he goes to the other one. But on this one here, is the mouth eating a y? No, so we'd have to shade the ground. Now what I'm going to do is I'm going to shade the ground in a different color. Do you guys understand primary colors and secondary colors? So I'm going to get crazy now, and I'm going to shade the ground of the other hill in blue. Everything that's on the ground, I'm going to shade in blue. Since I already have yellow on the screen, if I mix yellow and blue and there's an overlap, what color should appear? Green, right? Blue and yellow make green. Let's see. So I'm looking at this other hill, and here's my blue. I'm shading blue. Everything is nice and blue. Whoa! Spaghettios. Will you look at that? What color just showed up? So wherever the overlap is occurring, that's what you're supposed to shade, which is why when you go back and look at the original, that's what they have shaded in, where that green region was. If you get it, fine. If not, whatever. Like with the trailer courses, I try to go a little bit slower. Even if you think it's going fast, believe me, it's going slower. And sometimes you have to cut certain things. This is, I think, one of the things you cut. Yeah, hopefully. And if it does, it's not going to show up too much. So. Okay, this we did. Solve by elimination. I would have solved by elimination anyways, even if they wouldn't have told me to. So the question is, which variable would you prefer to eliminate? Okay, you want to get rid of the x. So Kira, if you want to get rid of the x, what would you?
Oh, no. I changed my mind.
Doesn't matter.